Thanks so much, Cole. I'm going to share my screen and start presenting. Can everyone focus these slides in the correct mode? Sounds good. Thanks so much. Like Cole mentioned, my name is Erica, and I'm a lead data engineer at the Urban Institute. And then I'm joined by Rob, and we'll be presenting. We're calling it a practical introduction because we're really hoping to keep this very grounded and not very theoretical, and not go into the history of Git and GitHub, which I think a lot of online resources tend to do. So hopefully this is helpful for folks here. So just in terms of goals for today, as I mentioned, we're really trying to keep it very practical. So we're hoping folks come away today with a good understanding of the benefits of Git and GitHub, when they're useful, why they're useful, how other NNIP partners have been using GitHub, introduce some key terminology, and then some basic workflows. Basically, just make sure that you can, go forth in your GitHub journeys and be able to read a guide and be like, okay, I know what a commit means. I know what these words mean. So hopefully provide a friendly introduction to terminology there, and then learn some best practices, and then hopefully come away with very tangible next steps for getting started today, adopting GitHub into you and your project team's workflows. So just for a quick high-level overview of what are Git and GitHub, and I think the first sentence really captures it, where they're basically just tools to enable version control and collaboration. We're going to talk a little bit more tangibly about what these mean in the next slide, but just for a couple examples of what that means in practice, it lets you track changes to files over time. So if I have a file today and then hypothetically I want to update that file because I want to continue working on it tomorrow, it lets you track those changes in a centralized and robust way. Specifically, the kinds of files that we're talking about with Git and GitHub are going to be codes. That's going to be R scripts or Python scripts or Stata scripts or SAS scripts or other kinds of code-based files. And it really, GitHub lets you share, discuss, and edit that code more easily. So sort of that collaborative feature of letting you and your collaborators work together on code instead of, back and forth of emails or Slack messages or Teams messages. It really provides a centralized way of communicating about that code and communicating about individual pieces of it. It lets you know who made changes, why, and when. I think a lot of folks here maybe have inherited code from someone who previously worked at the organization and have a lot of questions or have questions about how come this line is written the way that it is, or when was this change made? So GitHub makes it easier just to know why changes were made, who made them, and when that happened. And also, I think everyone has had some version of making a change to code or making a change to a project and being like, oh no, I didn't actually want to do that. And just having a quick and easy way to revert that change and go back to a previous version and just give you a little bit more comfort and confidence experimenting with code, because you always have that safe version that you can go back to. So these analogies are definitely imperfect, but I think they're helpful as a starting point. Is that the way to think about Git is sort of like the tracked changes feature in Microsoft Word. So basically, if I'm working with Cole on something or on like a Word document, and then I see that he changed something within that document, I have that nice sort of like red syntax to see exactly what he changed. So that's what Git does, is it's a software that sort of lets you see differences across time. That's a much more powerful version of that. That's sort of the way to think about Git specifically. And then GitHub is sort of analogous to something like Dropbox or Google Drive or Box, or basically just like an online collaboration tool that just stores versions of those changes over time. So those are kind of imperfect analogies and a little hard to think about in the abstract, but luckily Rob is going to make that more tangible in the next couple of slides.
Yeah, so this is not a comprehensive list by any means, and it's also worth kind of reiterating that GitHub is a tool used by many different people in many different types of organizations and companies. And so our focus today is kind of on the research realm, specifically what we do at Urban and what you do at your organizations. So these are, to me, the three top reasons why Git and GitHub is useful. Internal management, meaning that all your code is stored in one place. Everyone kind of knows where it's stored, and all staff theoretically have access to it. It's great for external collaboration, which is, I know, one of the most important parts of NNIP is working together, learning from each other, peer networking. And so the ability to share code developed for your city or your region so that people in other cities can use it, build upon it, improve it, is really a useful thing. And then reproducibility over time, because I know many of us, we don't just do a project once. We do a project and then we need to update it next year and the following year, or on whatever frequency that you work on. Next slide. And just a little illustration. I think everyone who's ever worked any job has come across this problem. You think your document or your code is final, and then by the time it's been passed around to everyone, the file name is absurdly long with everybody's initials on it, and nobody has any idea what's the current version, anything like that. And so definitely helpful to avoid this specific problem, which I'm sure we've all encountered. And next slide. And then Cole, I know, has asked a few of you to just briefly mention how you're using it. And I think it's really helpful to hear from each other. So go ahead, Cole.
Yeah, I saw Jeremy's on the call. We could just pass it over to Jeremy first.
Sure. Yeah. Just the way that we've used GitHub is in a few different ways. First, the sites that we create and the code that we use to create that, we post that into our GitHub account through community information now, to make that available to people that want to take those and stand them up on their own. So that code, anything that we do, we make sure that that code is available for people to be able to use. So we have our Bear Data Dive tool. We have our tool called Somos. We have a few things that we've done in our Shiny. All that code gets put up and is available for folks to be able to grab that. We also use our code to automate a lot of our processes with calculating ACS data and automating the way that we make charts for reports. So all that code, we have some of it up in GitHub. We're currently just wrapping up a project where we're going to put up a much more updated version of that, and that'll be available through our GitHub as well. And then finally, we work on a project with John Stark Philanthropy in Grand Rapids. And we use the Kanban tool in that to manage tasks and just be able to look at all the development backlog that we have, decide what the prioritization of that is, and then move it along the process and make any notes along the way. So those are the three ways that we've been using GitHub over the past years here on these projects.
Yeah, thanks, Jeremy. And we can go to Rachel next.
Yeah, thanks. And I know there's some other MAPC folks on the call. We have started using GitHub a lot more in the last couple of years. I think a lot of what you've already talked about is how we're using it. But when we're thinking about transparency, I think something that we really appreciate is that GitHub gives us a place for making our decision-making and analysis transparent. So project partners, other organizations, future analysts at MAPC can sort of see why we made decisions or how we made decisions in analysis. And then we have a web development team that uses GitHub pretty extensively. They used to be sort of our core users of GitHub. Now it's our whole data services team. And that's sort of in the collaborative project development mode. And then I would just really echo that version control being a huge benefit. I think, when I look at old scripts from before we used GitHub, you see so many different versions and a lot of confusion over what one should I be using and what was the order of changes that were made. So it's really awesome to be able to see those changes over time and to know exactly where our scripts are, because we have sort of an extensive shared network. And now we just know that all of our scripts live on GitHub. That's the most final version. That's the version that if future edits get made, we do it through Git.
Yeah, definitely. Well, thanks, Rachel. And then Cheryl is last.
Yeah, hi everyone. So Benia has a GitHub account that was stood up probably nearly a decade ago, I believe, initially by some of our data science staff, and has been used extensively by various data science students over the years that we've had. It's been a way for us to build off of existing work and projects, and we primarily use it as a way of disseminating code and resources and details files that are used to calculate our community indicators. So this is both code on cleaning data, so cleaning up addresses for geocoding, but then also the filtering process to develop some of our indicators. And so we kind of use our GitHub portal kind of just as one of those mechanisms, one of those tools that helps us to share data. So make sure that we are maintaining transparency, to make sure that others can replicate our work, and make sure that the indicators are something very accessible to folks in the civic tech world. So we have a lot of other resources on our primary website and on other portals of making the data open and accessible to lay audiences or GIS folks, but GitHub is really that that introduction to Binia and our processes for folks that are in our case predominantly using R or Python.
Awesome. Thanks very much. Thanks, everyone.
Thank you. Yeah, I really love hearing about those. I think the points around transparency and having a single source of truth really resonate. One other thing that I think really resonates, especially with their GitHub journey at Urban, is just the fact that I think it often starts at organizations with like web developers or data scientists, maybe more advanced programmers. And then I think there's some version of them, overlapping on projects with people who are maybe a little bit new to data practitioners or more at that like analyst kind of level. Like I think that they start seeing the value of GitHub, and through hopefully great trainings like this, then that sort of just means that more and more people can start using these tools and benefiting from them, whether they're writing complex web applications or if they're, just not just pulling, but they're just pulling ACS data and writing maybe a one-off report here or there. So in terms of jumping back into the introduction to GitHub, there are a few. We're going to try to keep this generally light on terminology, but basically I just want to make sure that everyone here has a common vocabulary for knowing these are the words you're going to encounter when using GitHub, and these are what they mean, hopefully in simple enough language. The basic idea is that Git, which is again that software that's sort of like word tracks changes, lets you take snapshots, which are called commits or commit messages or commits of individual files in a folder that's often called a repository or a repo for short. And the basic idea is just that whenever you want to save a version of a file or save changes, you just tell Git to take a commit of that and then upload it to a centralized repository. A key thing, or a couple of key things to remember, is that you're in charge of deciding when you want to take those snapshots or make those commits. So it's up to you to think about, all right, this is the logical chunk of work. I'm done for the day. Like I finished some piece. And you also are in charge of deciding which files get uploaded to Git or GitHub. And the key thing to remember about GitHub is it's that remote place. So if you think about your computer as being where you locally keep versions of code or where you locally keep files, and then GitHub is that remote version where you have a single source of truth, centralized version of those files. So just for a couple of pieces of vocabulary, you're going to see the word clone, which basically says, take the version of this code or of these files that are in that remote place and then clone them or move a copy of those onto my local computer. And then the other terminology you're going to see is push, which basically means take what's on my local computer, push it to GitHub, and then the opposite of that is take what's on GitHub in that remote place and then pull it. So just for a couple examples to hopefully cement that point, the little blue octocat over here is GitHub's official logo, but the idea behind GitHub is that every individual person or collaborator will have their own local version of that repository, of that set of files, and then they're going through the process of pulling and pushing from that shared centralized repository that's hosted on GitHub. So again, just another version of the same thing here, pulled from Jenny Bryan, who's done a lot for the R and data science community for folks who also evangelize her, is where these images come from. But the basic idea is you have different collaborators and they all push to GitHub, push their changes to GitHub, and then pull the latest changes from other folks there. Over to Rob.
Okay, we're not going to spend too much time on this because you can go ahead and do these steps on your own. And if you got my email from last week, hopefully you already have. But in order to use GitHub, these are kind of your prerequisites. So obviously first you want to go on github.com and create an account if you don't already have one. Next, you want to install Git and optionally, but I do suggest GitHub Desktop on your computer. These are two separate things, and if you want to use GitHub Desktop, you do also need to install Git, but again, those are all discussed in those instructions. And then you'll want to configure it. You will need to create a username and log in with a personal access token. And I know if this seems a little intimidating, don't worry, because those instructions are very detailed. Next slide. So this is a really, really basic workflow and in flowchart format, hopefully a way of visualizing it. But when you work in GitHub, you'll be working with repositories, or what we call repos, as Erica said, and you will use the commands. So you'll edit your code, you will add those changes, and you'll commit, and you'll continue doing that as many times as you need to. And once you're happy with how everything looks, you will push your changes to the repo. Next slide. And so this one shows a little bit more in depth the difference between a local repository and the remote. So local means your computer, whatever computer you're working on, a laptop, a Windows desktop, a Mac, that's your local. And you'll be working in a repo there, either one that you create or one that you clone from GitHub. And we'll show a demonstration soon that shows how to do both, creating a new repo and cloning an existing repo. And then from there, you'll go through the steps of editing, adding, and committing, and pushing your changes. Next slide. And Erica will do the first demo, and then after that, I will do the second demo.
Thanks, Rob. So yeah, so effectively what we're just going to do right now is just walk through the process of creating a repository from in that remote place, cloning it, and then editing a quick file, and then pushing it back up there. So I'm going to stop sharing the presentation. Oh, sorry, I meant to go to presenter mode and then go back to sharing the screen. So what I'm going to do here is this is the one of two Urban Institute GitHub organizations. And you can see there's hundreds of repositories, and these are just the ones I have access to. So I'm going to do now is just walk through the process of creating a brand new repository for the purpose of this demonstration. So I'll click the new button here. I'm going to call it NNIP GitHub demo very creatively. What a convenient auto-populate there. So in terms of the main things to know about this process is really just that like a lot of the defaults are going to be what you want to use. So you don't have to, especially when you're first getting started, GitHub does a really good job of giving you sensible defaults. So here I want to create it within this organization. That way I get all the benefits of this organization and collaboration within the org. You can create a description optionally here if you want to. One thing that's very important is that by default, GitHub will make the repository private, which can be great if you don't want to share the information, maybe there's something confidential or something that's just a work in progress, so you're not ready to share publicly. Alternatively, you can make a repository public, which means it's going to be anyone on the internet can see it. And important to note that you can go back and forth between those two. So if you want to initially create a repository that's private, and then after you're ready to release some tool or something, then you can go ahead and make it public later on. But again, the default of being private, I think, is a sensible one. We'll talk a little bit more about what a README file means at the end, but the basic idea is just it gives you a way to write information that someone else should read when they first approach this repository. So maybe like, what are the folders, or what's the purpose of the project, or who to reach out to for questions. And you can optionally initialize one of those files right here, which I guess I'm going to do. And then for now, we're not going to get into the weeds of what a git ignore or a license are, but just know that those are other things that you can set at the time of initializing a repository. So now I'm going to create the repository, and it takes just a second. And then this is like the GitHub repository default view from the user interface, so from github.com. So the first thing I'm going to do is I'm going to add Rob as the collaborator, because Rob is my collaborator for this demonstrations. I went to settings, collaborators, add people, and then this is Rob's GitHub username, which, and then I'm going to give him admin privileges, and that's the only option that shows up here for reasons specific to Urban's GitHub organization. And I think the descriptions of what to give, what permissions to give a collaborator are pretty user-friendly, and happy to talk about that later too. But basic idea is I just add him here. So now, in addition to me being able to see this code, Rob can also have access to everything that I put in this repository. So it's the process of creating a new repository. So now this is the thing that only exists on GitHub. It only exists on the web. It only exists on in the internet version of the remote place. So now what I want to do is I want to clone it locally so that it also exists on my computer. So I went to code, and then I copied this URL here. And then I'm gonna use our studio to walk through the process of cloning it, but you can use any kind of a terminal window, any kind of a command line or PowerShell or Bash, or depending on whatever Windows or Mac computer you're on, or you can use GitHub Desktop, which is basically like a point and click graphical user interface that Rob's gonna demonstrate in a second, but this is the like command line version of using GitHub within an RStudio environment. So I am just in my desktop here. So what I'm going to do is I'm going to type git clone and then paste in the URL from a second ago. And you can see that it says cloning into NNIP GitHub demo. And if you didn't blink at the wrong time, then you can see that now there's a new folder here called NNIP GitHub demo. When I click into it, there's just a simple README file, which is because I initialized it when I created the repository. But what I basically just did now is I took that repository and put it on my local computer. So copied all the files that were there. And now I have a way to interact between the files on my computer and then the file and then what's in that GitHub repository online. So this isn't particularly exciting, but what I'm going to do now is go through the process of adding a simple R script and then committing and pushing that file to GitHub for Rob to then be able to look at later. So I conveniently put together a quick example where there is not a lot of going on here, not a lot of craziness going on here for folks who are used to working in R with census data. Hopefully the syntax looks familiar, but I'm using the tidy census R package to just get median household income data for DC, Maryland, and Virginia at the state level based on 2020 ACS 5-year data. I'm just going to quickly run this code and show you what it does. What the code does is less important than the GitHub steps, but I think folks here probably enjoy looking at census data, so might as well. And sure enough, here's the little bar or dot plot with error bars of household income across those 3 states. So now all I'm going to do is just save this file within the folder. So I just hit Command Save, and then I put this here, and I'm going to call this like census example.r. So again, just save the simple R script. And then now I'm back in the GitHub piece of this. So the 3 things that I want to do are, first I want to get into the folder that I'm in. So now from my command line, and within that NNIP folder, I want to run git status, which is basically a simple way of saying, hey, Git, like, tell me what you think is going on. Like, tell me what files you think exist here, just to get a sense of making sure me and Git are on the same page. The next thing I'm going to do is run git add census example.r, which is basically saying, hey, Git, like, start looking at this new R file that I put here. Then I'm going to run commit, which again is a way of saying, hey, Git, take a snapshot of this file in terms of how it currently looks. And then I'm going to add what's called a commit message, which is basically just a way of saying, whenever someone looks at me adding this file, what's a simple message I want them to think of or have associated with that change? So here it could be something like adding an example script for the demo. And then now what I want to do is push that up to GitHub. So again, just those simple commands of git add, the name of the file, git commit, a little message saying here's what I'm doing, git push. And then now if I go back here to this repository and I refresh the page, then sure enough, now I have this new census example.r file here. And then if I click into it, I can see that I have the same R script that was in RStudio a second ago. So that's the basic, most simple workflow of here is me taking a file, putting it in that centralized repository. And now whenever anyone wants to know which example or what code should I use for, I don't know, for whatever purpose, then they can go to that single source of truth there. So maybe you can pause here and ask if anyone has any questions about the content we've covered so far. If not, I'll pass it back to Rob. Actually, that's not true. I'm going to keep continuing. I'm not going to pass it to Rob as I look at our notes. So again, what we've done so far is walk through what we've been calling like a simple workflow. So not that collaborative piece where it's just me and my computer going back and forth. Maybe it's because sometimes I work at my work computer and sometimes they work at my home computer. And I just want to make sure that I have the same versions of files there. Or maybe I just, accidentally spilled coffee on my computer a couple of years ago and now think it's important to have backups of everything for, I don't know, future posterity. So again, everything we've done so far is a non-collaborative workflow. It's really just me using GitHub as a way to take my code and make sure it exists somewhere that isn't just my computer. So the next piece of this is what we're calling a collaborative workflow here. And hopefully you can note that the only difference between this diagram and the diagram from before is just that you now have this additional step of pulling. So all we did before is I initialized and then in my case cloned the repository, edited a single file, added it, committed it, and pushed it. And now if you want to add an extra collaborator, what you would do is just have that collaborator pull the file that I pushed from GitHub back to their local computer. Which in a lot of cases works great. It just means that Rob now has a version of that file, which is nice. Like he doesn't have to, ask me, hey, Erica, like, how did you pull that census data? He can just go to that GitHub repository and know where that code is. The one problem that might come into play is suppose me and Rob are both working on a project at the same time. We want to have maybe different versions of it, or maybe I want Rob to create a similar version, but instead of DC, Pennsylvania, or DC, Maryland, and Virginia, he wants to do different states. So the idea here is using something called branches, which are basically just ways to have there be multiple versions of the same files or multiple versions of that repository that let folks work collaboratively without having to worry about overwriting each other's files or messing with some like centralized good to go version of the code. So the default branch in any repository is going to be called the main branch. And if I go back to GitHub here, you'll notice that by default, it says that the main branch is the one I'm on. So when you create a repository, the main branch is what you're by default just going to be pushing and pulling to. And in a second, Rob will demonstrate creating a new branch that isn't the main branch. But then the diagram that you'll see a lot, I think, is actually pretty helpful for thinking about branches is what you see here. So there's a centralized main branch, but then if I want to make a change, maybe I want to update to use 2021 census data, 2022 data, then I would create a branch off of that main one and basically be able to like work along and work on the changes that I want to without having to worry about messing up that main branch or having to make changes on versions of code that other people are using. And similarly, Rob can simultaneously be updating his code or working on his changes without worrying about it affecting me. And then again, just a couple other pieces of vocabulary. are the process of taking code on a different branch, so on like an Erica specific branch or a Rob branch, and then merging it back into the main branch. The GitHub terminology for doing that, or the GitHub tool for doing that, is called a pull request. And we'll show what that looks like in a second, but again, just not wanting to get super bogged down in vocabulary, but the basic idea is that pull requests are the tool that lets, or the GitHub tool that lets you merge changes from one branch to another. If the example on the last slide wasn't helpful, I came across this and thought it was just absolutely delightful. But hopefully this makes clear what branches do, at least conceptually, where the idea here is that you have a little octopus and you have a main branch. Maybe I'm working on adding heart glasses or heart-shaped glasses to the octopus on this branch over here. And Rob is working on adding a cowboy hat, or adding a cowboy hat to the octopus on his branch. And then when we come together, we merge those back into the main branch, and our little octopus now has both heart glasses and a cowboy hat. So hopefully this either makes branches more clear or is just, I don't know, a fun thing to look at right now. Hopefully one of the two of those is the case. And yeah, so hopefully one of the two of those is the case. So again, sort of sticking with that same diagram that we walked through earlier, hopefully a lot of this will look familiar, where the idea of initializing and cloning a repository and then going through the process of editing, adding, committing, and pushing files is all the same, should all be familiar. The only new steps here are that we start by creating a new branch. So we start by creating a new branch here. And then everything we do, instead of doing all of this on the main branch, we do on a person-specific branch or like a issue-specific branch. And at the very end, we just open a pull request and then merge it back into that main branch. So again, we're trying to keep these diagrams to build off of a simple workflow, but the only addition here between what we've done before is really just that we're adding that step of creating a new branch, doing the same thing that we were doing before on that different branch. And once we're ready to merge that back into the main version of the code, then merging it back through that pull request mechanism. So if that was abstract, hopefully Rob's demonstration now can make things more clear. But also maybe should we pause for questions now, Rob, and see if before you go through the demo?
Yep.
Sounds good. Any questions about octopuses or non-octopuses? Yeah, I thought Brandon raised his hand.
Sure. Thank you both for a great presentation so far. There are a lot of ways to do this, right? You showed a way to do it through the terminal. I use a lot of GitHub Desktop or through a separate GUI, and then you can do it in R too. You could initialize it. What do you find there's pros or cons within your own workflows or Urban's workflows that like make it easier to work as an organization when you're doing collaborative projects, or what are the pros and cons?
Yeah, I personally have a lot of opinions on this. My high level opinion is just that whatever gets you using GitHub is what you should use. Like, I think for some people, the idea of the terminal is really scary, and the idea of typing commands into some kind of a shell is intimidating. So if that's the case for you, I think using something like GitHub Desktop that Rob will demonstrate in a second is absolutely great. Like, if that visual interface is helpful for you, I think that is absolutely wonderful. And similarly, if you're almost exclusively working in R Studio, I think there's a lot of really good built-in integrations within R for using GitHub. If you're a Python user who's using Visual Studio Code mostly, similar, there's a lot of really great user interface, point and click kinds of tools within there. So I think that's particularly, yeah, I really just think that whatever works for you is great. That being said, I think that one advantage to the command line is I think you inevitably will get into some kind of a little issue where GitHub is telling you that you have a detached head or a merge conflict or something, and you don't quite know how, what buttons you click to get into that sticky situation. And I think that that's where using the command line can be really helpful. Like if someone's like, hey, Erica, GitHub is yelling at me and I don't know why. And I can be like, okay, can you tell me what commands you typed in so I can figure out how you got into the situation you're in and we can figure out how to get out. which I just think is helpful for someone to be able to send me exactly what they did, as opposed to them being like, I think I clicked this button and then that one, but I don't quite remember. So I think for reproducibility reasons, I think, and even just like live troubleshooting reasons, I think using the command line and having that written or having that record of these are exactly the steps that I took to do what I did, I think that can be helpful. But again, I also realize that for a lot of people, that can just be intimidating, and GitHub is already a new tool to learn. So having to learn one new tool and then also the command line as a new tool can be a lot. So I think there's pros and cons. I don't know, Rob, do you have anything to add?
I might, but I think I'll go on to the next demo so that we make sure we cover everything in time, and then we can do pros and cons at the end if we're still interested. But I'm going to do the second demo, which is the collaborative demo to show how Erica and I are working together on this R code. Because obviously, whether it's within your organization or across organizations, this is one of the main benefits of GitHub. And I'm going to be demoing it using the desktop app. And I think it's just worth saying at the end of the day, both tools are doing exactly the same thing. It's just a matter of whether you're typing or whether you're clicking. And so it's not like, oh, you choose one to do one thing and the other one to do another thing. They both do exactly the same thing, just a little bit different way of looking at it. And that's why we wanted to show both today, so that you have an idea. So I'm going to start back at the GitHub website. So I'm on the Urban Institute Research account where Erica created the new repo, which is called NNIP GitHub demo. And when I click into it, right away, I get to see 11 minutes ago that census example.r was created. And if I click on it, I get to see all the code that was pushed to the repo. So that's really cool. And it's on the main branch currently. We currently have only one branch. So this is the GitHub desktop application. And what I'm going to do to work in it from this repo is I'm going to clone the repo, NNIP GitHub demo, and I'm going to clone it using GitHub desktop. Now, there's many ways to do this. The way I like to do it is to just click the big green button. I feel like they made it green to make it nice and inviting. And I click this option to open with GitHub desktop. And I'm on a Windows computer, so it'll open right up. And it will ask me where I would like to clone it. So I'm just going to use my default location in my documents folder to clone the repo there. And when it's finished, what's really cool is that I can click right into the history tab here, and it will show you all the edits that have been done so far, or all the commits so far. And there have been 2 that Erica made, one 18 minutes ago, one 13 minutes ago, and it's all right there. Now I'm going to edit the code, and I'm going to do that on a branch. So the way I like to create a branch using the app is to click on the current branch, which is main, and then I like to type in here the name of my branch. And then I can click create new branch, big blue button again. And now I've created my branch. And in order for it to be visible on github.com, I need to publish the branch. So another big blue button. Usually you can navigate around pretty easily by just following the big green and blue buttons, and that'll get you where you need to go. And then if I go back to the website, notice how it says 1 branch, but when I refresh, it will say there's 2, because my new branch has been published. So we have the main branch and we have my edits branch. So back to GitHub desktop, if I navigate in Windows to the folder that I cloned, we have 2 files, the README and the R script. So I will double click on the R script to open it up. And now I know that Erica wrote this really cool census median income code, and it pulls it by state for 3 states, but, or sorry, by county. Let's see, make sure I'm on the right. Yes, it pulls it by state for 3 states. And maybe I would like to do something a little different. Instead of pulling state data, I want to pull county data. And instead of 3 states, I just want 1, Maryland. And I want newer data. So instead of 2020, I'll put 2021. And ACS 5-year data is great, but since this is county level, I trust the 1-year data is good. So I can make all those edits. And if I run the code, got a cool county level plot down here. And if I open up the file, we have the median income for all 16 counties in Maryland. So that was cool. I'm happy with my edits. Everything worked. The code ran, no errors. Everything looks good. So I can go ahead and save. And then when I exit RStudio and go back to GitHub Desktop, it now shows some edits that I've made here. So here's the R script, and here's exactly what I've edited. So the red lines, that's what I deleted essentially or changed. And then the green lines, that's what I added or changed. And so I changed the geography of the census data. I changed the state command, the year command, and the survey command. So those are all changed. And we also have a .r history file here, which in an advanced session, we will show you how to create a git ignore so that this doesn't appear here. But for now, I'm just going to discard the changes since I don't need to commit those. And I'm going to commit my edits, and I want to make a detailed commit message so that if Erica sees this, she knows exactly what I did. So I'm going to say change ACS to county, Maryland, 2021, 1-year data. That's my commit message, and I'll commit it to my branch. And then it's committed, but I still need to push if I want it to go up to the remote, which is the github.com website. So I can, again, many buttons to do this, either the blue push origin button here, or there's a button up here. Either one does the exact same thing. And then once I do that, I can go back to github.com. And if I look at the code, it appears that nothing's happened. But that's because I'm still on the main branch and I need to switch to my branch, which is this one here. Once I switch over to my branch, if I open up the R code, you can see all my edits are right here. So I'm pretty happy with how everything turned out. My branch is now complete and ready to be merged back into the main. And again, many different ways to do this, but I'm going to show you how to do it using the github.com website, because that way it's the exact same process, whether you're using the command line or the app. So I'm going to use the big green button, compare and pull request. And when prompted on this screen, I'm going to tag Erica to let her know that my edits are finished. And I can press the big green create pull request button. Now Erica is going to get a notification in her GitHub or possibly an email, depending on how her settings are created, that says, hey, Rob tagged you on this pull request. And then it'll show my message that says my edits are finished. And the last thing to do is to merge the pull request. I can do that with this button. I confirm the merge. And it's successful. So that means when I go back to the repo and I'm on the main branch again, when I open up this file, you should see my edits are now here. So now the main branch has this code with the county level median income data in Maryland, 2021, 1-year ACS. And that is the current main branch. And if Erica were to edit the code again, add on to it, make another plot, whatever, then she can create another branch and do it there. Okay, I'm going to stop sharing so that you can pull the slides back up.
Good. All right. So again, this is the workflow that we just walked through. This is the demo that Rob just walked through. And then maybe for the sake of time, we can just skip over this, but this basically just walks through the key commands that we covered today, which should be for, like, in probably 99% of my GitHub use case, these are the only commands that I use. Like, I think sometimes when you see things like GitHub cheat sheets online, there can be like 700 commands, which can make GitHub seem potentially a little bit more intimidating than I think it necessarily has to be. So we'll just skip over this for now, but know that we'll share the slides afterwards if this is helpful for you. And then back to Rob for some last best practices.
Yes. So again, GitHub is a tool that is used in many different contexts by many different companies, and best practices will differ depending on exactly what you're doing. And since we all do relatively similar work, we can follow pretty similar best practices and learn from each other as to what's good. So the most important thing is to always follow your organization's policies and don't put any kind of confidential information on GitHub. That includes data files like a CSV. If you have a CSV that includes confidential data, you don't want to push that to GitHub, because once it's on GitHub, it's essentially on the open internet with an asterisk because it's in a private repo, et cetera. But usually our IRBs are quite picky about that sort of thing. But also that doesn't just include data files, but also your code. So for example, if you are working with data and you're using like a tax ID or a social security number as an ID for a person or a company or an organization, maybe you should create another pseudo ID to work with before you write your code, so that you're not potentially, putting those numbers into the code itself. Sometimes I know people will hard code ID numbers into code for various reasons. And then also, whether your repo is private or public depends on, your use case. So if it's just within your organization, a private repo is probably fine. If Erica and I were the only two people working on this code and we both work at the same place, that's okay. But if we're going to be working with other organizations, or we're potentially going to be making this code open source so that anyone can use it, then a public repo might be more appropriate. README files are always very useful, and I know they can sometimes be an afterthought because you just want to dig right in and start writing your code, but a README is extremely useful for documenting what you're doing and how to run the code. So when I made a commit in my demo, I used an extremely detailed message, and that is so that if Erica was looking at it, or if future me was looking at it to remember what the heck did I do here, it's much more clear to remember what I did. And yeah, work with your collaborators and use GitHub in a way that meets your needs. There's no single right or wrong way to do this stuff. It's all about making life better for you and at your organization. And in this last bullet, we have some other useful resources. So you can click on that once you get a copy of the slides. And I think there's one more to go. And yes, and some more resources here. So these are all great places to learn more, get started, etc. I think it's 1:50, so there's 10 minutes for a big group Q&A, and then Erica and I will be around until 2:30 if anyone wants to stay past 2 o'clock to ask any additional questions. But obviously there's no obligation, so if you have a 2 o'clock meeting, feel free to sign off whenever you need to.
Sounds good. So if you have questions, feel free to answer them. But since we do have some time, Rob, I wonder if you want to give any thoughts on the GitHub desktop versus command line, and when you how you decide which one makes more sense for different folks.
Sure, I see Jesse has a hand raised, so I'll just quickly say, Erica is an expert programmer, so command line is really useful because she doesn't have to have a second program open. It can just all happen in R or all happen in whatever environment she's writing the Python code in. The disadvantage really to the desktop apps is that you just have to have a second thing open and kind of bounce back and forth between the two. And I know for many people, this is like the least of your problems. But if you're trying to be super efficient and like hyper focused and always be in one place, then that's the good case for the command line. But I agree with Erica's point before that it's whatever you're the most comfortable with is the best choice. And I definitely work with people who do both. Some people only do one, some people only do the other, some people do both. And I think everyone's right. And I think we can go to Jesse now.
Hey everyone, thanks for the webinar. This has been great. MAPC has been using, as you heard from Rachel, GitHub for a while. Started out with our web developers using it for website development, and then over the last few years, we've been transitioning more and more of our analysis work to living on GitHub, which has been useful for all the reasons Rachel said. However, we now have just like hundreds of repos on our MAPC organization page, and it can be hard to navigate, or if like you don't know the exact name of the repo you're looking for. So we've been thinking about like how we could organize it by topic, or like separate the website code from the analysis code, or generally make navigation easier. So I'm wondering if you have any best practices you could share with us on that. Thank you.
I will say, I think it's a really hard problem. I think that a lot of folks probably have similar problems. A few sort of initial thoughts, none of which are very good, are just using, and you allude to this, that GitHub lets you add topics to repositories, which can just be helpful for like quickly searching. So maybe it'll be by project, maybe it'll be by the type of data source used or something along those lines. I think whatever makes sense for the folks that you're working with there. I also think this is less around the navigating repositories, but what Urban Institute does, I think, is really helpful is more around organizing collaborators. We use GitHub Teams a lot as opposed to using individuals. I don't know if you also do the same thing, but I think that can just be helpful for making sure that everyone has access to the repositories they should need. It makes it a little bit easier to not have to, if I have 10 people who I work with all the time, not having to individually give 10 people access to all the repositories. And I think sometimes what we find is that people just create a new repository because they don't realize the one that already exists, because they don't have access to the one that already exists. So just using Teams can be helpful there. Urban also has a pretty centralized GitHub administrator process for mostly managing, getting people access, removing their access. I don't know if Rob's one of the admins. I don't know if you have other thoughts, Rob, on how that process has worked out.
I think this is well, I agree with Erica. This is a very hard problem. And I think it also is a problem that scales with the size of your organization. So I'm not sure the size of your organization, but like the Urban Institute has like 500 something people. Not everyone uses GitHub, but I think something that is helpful is to name your repos as specifically as possible. So an example that's relevant to this group is, I believe the first repo called NNIP was done by some web developers because they were making a website, and it was just called NNIP, and that was unclear like what went in there, right? And it was website stuff, but we ended up renaming it. But if it had been, more specifically named at the beginning, we wouldn't have had quite the same issue. Now, if you are a small organization and you only have like 10 people or a dozen people, then just having a single like manager, right? Like one person who says like, I'm in charge of all the GitHub things. I think that's a lot more feasible. So for a small organization, maybe having like a single point person. For a larger organization, having, at Urban, we use like a group. So it's like I forget what our term is, but like a group that's kind of in charge. But just to give guidance for people, because we're not going to ever prevent someone from making a new repo. We want to encourage people to use this tool. And so if we have a bunch of rules and, things that people have to follow, they might be intimidated, or they might say, it's not worth it. So we try to be flexible on that, but just to give as much guidance as possible is what my suggestion would be. Again, this depends on the size of your organization.
And Jesse, I would say from the work we've done in DC, where we actually have a separate repo that's not on Urban Research. And we've organized most of our files into like the source of, like, if we're getting the data from our Department of Housing and Community Development, there's one DHCD folder, and all data that comes from there and all programs associated with that go into there. There's an ACS folder. And then we do have separate project folders too, and those will pull, but that's only for like the analysis code. We don't have to put the initial ACS code to process the ACS data.
These are folders in GitHub?
Or repos, sorry.
Repos, okay, got it.
They used to be folders on our server, but now
right, yeah.
Folders.
Yes,
That's kind of what we're trying to replicate, but it's,
yeah.
the terminology can get a little tricky. So there's a separate GitHub organization for Urban Greater DC, and then there are repos within that organization. So this long drawn out story not needed to be told right now, but yeah, it does take some time to get used to the terminology, your organization, your repo, directories, folders, all that stuff. Just takes practice, just like anything.
Thank you.
And I would just make a plug. I think for me as a manager, I'm not writing as much code these days, but to be able to review code and setting up a review workflow has been invaluable for us, so that when the pull requests are done, Rob is often a reviewer on our DC work, or myself or Peter, we get to take a look at the code before it's merged with the main. And we find we catch a lot of things in that process. And that's also a process to be able to go back and forth when people have questions. So that part of the workflow, I think, is incredibly helpful.
Yeah, just want to mention real quick, because I see people hopping off before we have any more questions, that we will have the recording and the slides. We'll post a link to that to the NNIP Google group. So for anyone who wants to review this later, those will both be available.
I have a silly question. I use GitHub Desktop because I'm one of those people that the command line freaks me out a little bit.
Before you ask, do we want to keep recording for the bonus?
Yeah, we can stop.
Okay, yeah, let's stop the recording.